Hello, Old Dominion University professors. My name is Zachary Jones, and I'll be presenting my Fall 2015 Senior Design Project. I focused on the construction aspect of the Senior Design criteria. For the rest of this video, I will actually be down here, and we'll have the PowerPoint focused on your guys' screen. Before we get into the main part of the project, we're just going to go ahead and do a quick project overview. We're going to go over the introduction. I'm going to kind of explain what exactly this project entails, where it's located, how old the bridge is, and all that. We're going to go over the risks, what kind of risks come with this when we accept this bid, or if we even win this bid, the type of burden that comes with it, certain bonds and profit. We're going to talk about the relationship between the estimate and the schedule. Then we're going to finally talk about the estimate itself. We're going to go into each bid activity and kind of break it down of how we're going to build this thing. Then we're going to go into schedule. The schedule is directly related with the estimate. All the schedule is based off the estimate. And then finally, we're going to go over how to optimize the profit, how to get the most bang for our buck. And then finally, we're going to conclude. To get started, I'm going to show you guys exactly where we are relative to the bridge. Old Dominion University is over here on the right side of Virginia. The company that we're going to be using is my company, actually, which is I+Icon Southeast. And the bridge is all the way to the western part of Virginia, in a little county called Blackstone off of Route 460. Here we have the aerial view of the existing bridge, courtesy of Google Maps. It's located on Cox Road. That's where the bridge intersects on, which is in Blackstone, Virginia. To the right, we have a couple pictures of the existing bridge. The existing bridge is roughly 85 years old, according to VDOT's website. It utilizes two 12-foot lanes with no shoulder. It accommodates roughly 4,000 vehicles per day. There's no pedestrian access, which means no pedestrians can really cross this bridge. And it runs over Norfolk Southern's railroad. The new proposed bridge is going to be a complete overhaul, which means we're going to have to demolish the old bridge and then put a new bridge in. It's going to be one continuous span from station 123 plus or minus 26 to station 124 plus 69, which is roughly 143 feet, according to the plans. The clearance for Norfolk Southern's traffic is set to 23 feet, 10 inches. The width of the bridge is 45 feet. This new bridge will utilize two 12-foot lanes with two 10-foot shoulders, which will accommodate cyclists and pedestrians. VDOT expects this work to be finished in the summer of 2017. So now we're going to go ahead and talk about the risk that's associated with this project. The main risk that I kind of came up with was the MOT lane closure and detour that we're going to have to put in place. Whenever you're dealing with traffic, there's always going to be some sort of risk and liability that comes with it. To kind of mitigate this risk, we're going to go ahead and sub out this work to Richmond Traffic Control. They'll be responsible for all the MOT plans, including signs, barriers, and liability for the full lane closure. Some more risks continued. We'll need to work closely with Norfolk Southern's train traffic. We're going to need to monitor this quite a bit to kind of see what their traffic's like and how it'll work with our schedule. The demolition and construction of the proposed bridge will need to comply with all OSHA standards in order to prevent injuries and fatalities. The use of rented equipment always comes with some sort of liability. If we were to crash this equipment or wreck it in any way, we are found liable for this, and we could be assuming their costs. With some more associated risks, we have SWPPP, which stands for Stormwater Pollution Protection Plan. Whenever you're dealing with things with the environment, you're going to have to implement this plan with all government jobs. Because this is a VDOT job, they require an emergency preparedness plan, which will be developed by our safety director and project manager. To avoid liquidated damage, we're going to need to stay on schedule. Assuming all salaried employees have a 401k, health insurance, and PTO, the hourly wage is increased by 30.6% to cover all burden costs. I referred to the Estimating and Building Construction Manual provided by CET 460 class to kind of come up with that figure. All rental equipment, daily and monthly rates are already factored in based on rental companies. For this project, we put a bond rate of 1% of the contract value before the markup. We set all profit to 20% for each bid activity, which is the maximum VDOT will allow for this contract. Further optimization/change orders will be utilized to enhance profit margins, which we'll discuss later on in this presentation. When talking about the estimate and the schedule, there's a close relationship between the two. The estimate is based off of normal working days, which means Monday through Friday, and they're based on 8-hour days for non-critical activities, which are also known as float activities. Critical activities with no float time incorporate 10-hour workdays with overtime accounted for. This is the bid tab that will be turned into VDOT upon the bid due date. There are a couple lump sum items: cubic yards, linear feet, eaches, square footage, and so on. Each bid activity is broken down by these units and then multiplied by the amount of material for that bid item. Now we'll go ahead and take a closer look at the estimate which I put together. You can also reference all my material takeoff, which can be found in the submittal package turned in on Blackboard. Each bid activity has been given an engineer's estimate. Upon closer examination, some quantities overrun and underrun. The contract was charged as such. The first bid activity required by VDOT was the mobilization charge. This is a lump sum item with a crew size of 9, labor hours equaling 1,100. The total cost for this will be $86,594.69. To break this estimate down, I kind of came up with equipment that will be needed for this project. We came up with 2 cranes that will be needed. A 100-ton crawler and an 80-ton crawler will be needed on site full-time. There'll be 2 Doosan excavators with a long reach and a short reach, a front loader, a vibratory hammer which will be on rent for about 2 weeks, a dump truck to carry in and haul away material, a lowboy which will eventually get all the equipment there. Some support equipment will be an office trailer which is a 10-foot by 44-foot. We'll have a couple trucks out there full-time, and then small equipment. To come up with this estimate, I figured there would be 20-ton load capacity for each semi-truck, 10 cubic yards for a dump truck, and then 6 hours round trip from the yard in Virginia Beach, which is I+Icon Southeast's headquarters, to the project. The construction survey is a lump sum item as well. I put a plug number of 5% in, which totals $557,589. The demolition of the existing bridge was kind of a plug number as well, based off of RS means. Given the magnitude of the bridge, there'll be a 17-man crew. 2 crews will be utilized, consisting of 6 men in each crew. The total duration of this project, which is a critical activity, is 2 months, totaling $1,319,273. Clearing and grubbing was based on the fact that there is 2.46 acres that needs to be cleared and grubbed for this project. A labor crew of 6 men, 5 laborers, and 1 foreman will be assigned to this task. The total cost for this bid activity is $26,449, and we've given this 1 week to complete. Now that the demolition of the old bridge and the clearing and grubbing has taken place, excavation can begin. I've given 3 weeks to this bid activity based on the RS means data. For abutment A, there's 403 cubic yards, and for abutment B, there's 306 cubic yards. I've assigned a crew of 7 men, 5 laborers, 1 foreman, and 1 superintendent. This bid activity will run $131,697. The total excavation was figured out by taking abutment A and B and adding them together. To take this off, we had to look at these plans. I broke it down into cross-sectional areas of the abutment A and abutment B, as seen in this figure. Once everything is excavated out, test piles can be applied to the ground. 2 test piles into the ground, which will require a dynamic load test. Abutment A's test pile is 77 feet long, where abutment B's test pile is 63 feet long. It'll take about a day and a half to install both of these piles into the ground. Once they're in the ground, we're going to restrike them the next day, and then wait a week to restrike them again with the dynamic load test. The dynamic load test for each one is $29,000, totaling $58,000. VDOT does not list a specific type of H-pile that needs to be used, however it does give a 12-inch depth that does need to be met. Upon reference to the steel manual, I decided to choose a HP 12 by 74. There are a total of 22 piles located in abutment A and abutment B. To drive the H-piles, for abutment A, which there are 11 H-piles in both abutment A and 11 piles in abutment B. For abutment A, there's 770 linear feet. For abutment B, there's 627 linear feet. When referring to the RS means manual, the cost for an H-pile of that size will take $27.20 per linear foot. with a crew size of 8, 4 laborers and 1 operator, and then of course supervision from foreman and superintendent. The total cost for this is $106,850 with a 3-week timeline. These H-piles will be driven into both abutment A and B with a spread footing shown here in the plans. These H-piles utilize a 24-inch diameter sleeve, which will be later filled with porous backfill. The total amount of pile sleeves comes out to 662 linear feet. When checking with RS Means, it takes $54 per linear foot with a crew size of 7, 1 operator and 4 laborers with 1 foreman. The total cost to drive these pipe piles, or these sleeves, is $79,365 with a duration of 1.5 weeks. These sleeves are 24 inches long, and those should be provided by Skyline Steel. MSC wall is required for this project. For abutment A, there's 5,926 square feet. For abutment B, there's 10,776 square feet. It takes about $44.17 per square foot, with 2 crews consisting of 6 men. The total amount for this MSC wall will cost $1.2 million with a 9-week duration. This is a critical activity which needs to be done. Here's an isometric view of the MSC wall, which will be located on abutment A and B. Here's an elevation view of both abutment A and B where the MSC wall will be placed. To backfill these walls, I calculated it'll take 1,300 tons for abutment A, and for abutment B it'll take 1,600 tons. The cost to install this backfill will be $14 per ton. The duration of this project will take about 9.5 weeks. The steel reinforcement is in abutment A and B with their approach slabs. And I calculated this steel reinforcement by referring to the bending diagram located in the back of the plans, which is also in the submittal package. For the first concrete pour, we'll be pouring the abutment A and abutment B. For abutment A, there's roughly 81 cubic yards, and for abutment B, there's roughly 84 cubic yards. For the formwork, I calculated 576 square feet and 576 square feet for the abutment B. For this pour, we'll be pouring the approach slab and the abutments. Once this concrete is dried and cured, we'll install the 6-inch drain pipe which goes on the abutment slab as well as the span itself. I calculated 140 linear feet in the abutment A with 180 linear feet in abutment B, totaling 320 linear feet. The porous backfill is applied both to the 6-inch pipe as well as the pipe sleeves talked about earlier in the presentation. Moving on to the next critical activity, which is hanging the girders and the cross bracing. I came up with 278,400 pounds, which is roughly 139.2 tons of girder and cross bracing. I've given a crew size of 14. There will be 2 separate crews with 1 foreman and 5 laborers per crew. To start, we'll put up 5 girders spanning the length of the bridge, 145 feet long, 5 girders spanning the entire bridge, which is roughly 130 feet, and then go back in and add the cross-sectional bracing. Here's an example of the cross-frame bracing for CF1 and CF2. Once these girders are hung, we've reached a milestone. Now it's onto the decking. There's roughly 728 square yards on the deck of this bridge. I assumed it's roughly 30 square feet per deck pan, which will take roughly 20 minutes to install each one. Once all reinforcement is applied to the deck, I calculated how much concrete will be needed for the 3 separate deck pours. For the total deck pour, including 10% waste, there's 185.8 square yards. The cost per square yard to furnish and install this is $90 per cubic yard. To pour this deck, we're going to be doing this in 3 sections to avoid deflection in the overall bridge. Section 1 will be to the far left, closest to abutment A, and then we'll move the bidwell down to abutment B, where we'll do this triangle. Once these 2 spans are dried, we can move on to the 3rd span, which is the longest span. To pave this deck, we're going to need to bring in a bidwell from the yard, as well as a pump truck, which will be on rent. Here's the pedestrian fence detail, which shows 2 different types. You have the type B and the type C. The type C will go on the northern face of the wall, and then type B will be on the other side, the southern side. The pedestrian fence will tie in directly to the parapet which was installed beforehand. Now on to the schedule. Once this bid will go in, hopefully we'll receive a notice to proceed, which should take roughly 5 days to take effect. Our official start date is Monday, 9/7/2015. Once the notice to proceed is all in, we can begin mobilization, which will take 10 days to get all the equipment there. Under mobilization, we have 2 100-ton crawlers, 2 Doosan excavators, 1 wheel loader, small tool and a Connex, the bidwell, which will come later on, and an office trailer. The initial survey will go alongside with the start and mobilization. We'll have a survey crew out there consisting of 3 men. The initial survey will take 4 days. The demolition of the existing bridge is going to take roughly 60 days. To demo the parapet, I put in 10 days. To strip the road, I put 10 days. To remove girders in 3 sections, I put 20. To demo the existing abutment, also took 20. The clearing and grubbing will go on simultaneously as the bridge is getting demolished. Once the clearing and grubbing is over, abutment excavation can begin. We're going to begin by excavating abutment A. Then we'll continue on to excavate abutment B. There are 2 test piles that need to be driven into both abutment A. This activity will go on during the excavation of abutment B so that we can restrike the test pile with the dynamic load testing a week later. Once we get a pass from GET, we can go ahead and drive the other H piles, which consists of 11 piles in abutment A and 11 piles in abutment B. Once these piles are driven, we're going to furnish and install the pile sleeves in both abutment A and B, fill them with porous backfill. Once we're done installing the H pile, we're going to go ahead and install abutment A MSC wall about a third of the way up, and then we're going to partially backfill by grading. Once we install the backfill, we're going to install the remaining MSC wall and then fill the rest of the backfill into abutment A. Once abutment A is completely done, we're going to move on to abutment B by taking those 2 crews and putting them over there. With abutment B, we're going to do the same exact thing we did with abutment A by building part of the MSC wall, then installing the backfill and grading, and then building the rest of the MSC wall and filling it to grade. Once all the backfill is done, we're going to reinforce the abutment A and B, and then we're going to furnish and install the 6-inch pipe, which will take 8 days. Once this pipe is installed with the porous backfill, we're going to pour the abutment cap for both A and B abutments. I have 7 days for abutment A, and then abutment B, we have 9 days. I came up with this figure because there's more concrete for abutment B than there is abutment A. Now that the abutments are poured, we're going to reinforce the approach slab for abutment A. Now the abutment caps are poured, we're going to reinforce the approach slab for abutment A. Reinforce the approach slab for slab B, which will take 4 days. As we reinforce approach slab B, we're going to go ahead and pour the approach slabs for A, and then once we're done with A, we're going to move on to B. Once all the approach slabs are cured, we're going to move on to hanging the girders and the connector frames. This activity is going to take roughly 40 days, and once we finish on 10/24/2016, we've reached our first milestone. We're going to begin by hanging girders 1 and 2, which will take roughly 12 days, and then install 5 CF connectors between 1 and 2 girders. Simultaneously, when this is happening, we're going to be hanging the 3rd girder and then installing the other 5 CF connectors here, which will take roughly 3 days. This process continues on for girders 4 and 5 while installing the CF connectors between these 2. Once these girders are furnished and installed, we'll move on to hanging the deck pans. This is where we can optimize the schedule a little bit by hanging deck pans on girders 1 and 2 simultaneously as we're hanging girder 3. For now, we have it in here as 14 days after all the girders are hung. Depending on crew size, we can move that activity underneath girders 1 and 2 and have them simultaneously going on at the same time. But for now, we have them as deck pans girders 1 through 2 will take 5 days, 2 through 3 will be 5 days, 3 through 4 is also 5 days, and then 4 and 5 will be 6 days. We're using that extra day to make sure that all the quality control lines up with all the deck pans. Once all these deck pans are installed, we're going to move on to reinforcing the deck. We're going to reinforce the deck from abutment A to abutment B. Once all the reinforcement is done, we're going to bring the bid wheel up and start with abutment A in that first section that we talked about earlier in the presentation. To do the first deck pour, it'll take roughly 13 days. This is with wet curing, as well as quality control and inspecting the bid well and moving the bid well and such. Then we'll move on to the deck pour section number 2, which will take 12 days. Finally, we'll do the middle span, which is deck pan section 3. That is going to take roughly 13 days. Once all parapet is installed, the pedestrian fencing can go up. The pedestrian fencing is a little bit complicated, so I put in 30 days. Finally, towards the tail end of the pedestrian fencing, we can start seeding. As the seeding is going on, demobilization can start to begin by taking out the 100-ton crawler and all other equipment that is not needed. Finally, we reached our last milestone, which is the finish, which we expect to complete on 4/12/2017, which is a little bit before summer of 2017, depending on crew size. We can keep it this way. To optimize profit, we set it at 20% for each activity, resulting in a potential profit of $946,374. As long as we can keep the risk and overhead down, profit margins should stay within $850,000 to $950,000. Profit can be enhanced through change orders as well as unforeseen risks that are not denoted in the plans or specifications. Because our schedule finishes earlier than summer of 2017, we are hoping to receive some sort of bonus from VDOT as an incentive to finish earlier and reopen the road. In conclusion, this project is worth $8.9 million with a timeline of 435 days and should turn a profit of roughly $900,000. I would like to thank my mentor, Matt Lewis, for helping me establish a project schedule as well as how to format the estimate within Excel. I'd also like to thank Professor Zhang for helping me format my PowerPoint presentation by giving me all the topics to discuss within this senior design project. Thank you for watching my senior design project. Thank you for watching my senior design project. Thank you for watching my senior design project.